Imagine a future so distant that even the concept of the future begins to lose meaning. The stars are gone. Galaxies no longer shine. Black holes have evaporated into faint radiation. Space stretches endlessly in every direction, colder and darker than anything the human mind can truly imagine. Yet even this is not the end. According to some of the deepest ideas in modern physics, there may come a moment when reality itself reaches its final boundary, a moment when existence arrives at its absolute limit and can go no further. What happens when reality reaches the end? To answer that question, we first need to understand what reality actually is. Most people think of reality as everything around them matter: energy, space, time, planets, stars, and galaxies. But beneath all of these things lies something even more fundamental. Reality is a system of rules. The universe functions because certain laws remain stable. Gravity pulls matter together. Electromagnetism binds atoms. Quantum mechanics governs particles. Time moves forward. Space provides a framework in which events can occur. Everything depends on these foundations. If even one of them were removed, the universe would become unrecognizable. If all of them failed, reality itself would end. Today, the cosmos appears incredibly stable. The laws of physics seem fixed and eternal. Yet, every scientific theory has limits. General relativity works beautifully on describing stars, galaxies, and the large-scale structure of the universe. Quantum mechanics successfully explains the microscopic world. But under the most extreme conditions, these two theories begin to disagree. At the center of a black hole, mathematics breaks down. Inside the first moments after the Big Bang, equations become incomplete. The deeper scientists investigate reality, the more they discover boundaries where understanding begins to fail. These boundaries suggest a disturbing possibility. Reality may not be infinite. It may have limits. One possibility involves the ultimate fate of the universe itself. For nearly 14 billion years, space has been expanding. More surprisingly, this expansion is accelerating. A mysterious phenomenon known as dark energy appears to be pushing galaxies farther apart every second. As billions become trillions and trillions become quadrillions of years, the consequences become impossible to ignore. Galaxies disappear beyond the observable horizon. Stars exhaust their nuclear fuel. New stars become increasingly rare. The universe grows darker, colder, emptier. Eventually, the final stars burn out. For unimaginably long periods afterward, only stellar remnants remain. White dwarfs slowly cool into darkness. Neutron stars drift through space. Black holes dominate the cosmic landscape. Yet, even black holes are not eternal. According to Hawking radiation, black holes slowly evaporate. Tiny amounts of energy escape from their event horizons. The process is incredibly slow, but given enough time, even the largest black holes disappear. Now imagine the universe after the final black hole has vanished. No stars, no planets, no galaxies, no black holes. Only a thin scattering of particles moving through a nearly empty cosmos. Many physicists call this state heat death. Entropy has reached its maximum. Energy is evenly distributed. Nothing meaningful can happen anymore. No new structures form. No new civilizations arise. No new sources of complexity emerge. The universe continues existing, but it no longer evolves. At first glance, this appears to be the end. But some theories suggest something even stranger. What if reality itself cannot survive forever? Quantum field theory predicts that empty space is not truly empty. Hidden within the vacuum are quantum fields that determine the properties of matter and energy. According to certain calculations, our universe may currently exist in a false vacuum state. A false vacuum is stable only temporarily. Somewhere beneath it may exist a lower energy state. If reality ever transitions into that lower state, everything changes instantly. A tiny bubble of altered physics would form. Inside this bubble, the laws of nature would be completely different. Atoms might become impossible. Stars could no longer exist. Chemistry might fail. Matter itself could become unstable. The bubble would expand at the speed of light, rewriting reality wherever it travels. No warning would be possible. No observer would survive long enough to understand what happened. Reality would simply be replaced forever. Another possibility is even more profound. Space and time themselves may not be fundamental. Some modern theories suggest space-time emerges from deeper structures, hidden beneath observable reality. In other words, Space and time could be temporary phenomena rather than eternal ingredients of existence. If those deeper structures become unstable, space-time may disappear entirely. Without space, there is no location. Without time, there is no sequence of events. Without both, there is no universe as we understand it. The concepts of distance, motion, past, and future cease to have meaning. Reality reaches a point where its own framework collapses. This may be the true end, not the destruction of matter, not the death of stars, not even the disappearance of galaxies, but the failure of the very system that allows existence to exist. What happens when reality reaches the end? Perhaps there is no explosion, no final flash of light, no dramatic collapse visible across the cosmos. Perhaps reality simply arrives at a boundary beyond which nothing can continue, a final limit where laws lose meaning, structure disappears, and existence itself can no longer be defined. Beyond that point, there may be no darkness because darkness requires space. There may be no silence because silence requires time. There may be no emptiness because emptiness is still a kind of existence. There may be nothing at all. The universe would not merely end. Reality itself would reach its final destination, cross its ultimate boundary, and vanish into a state beyond every concept the human mind is capable of imagining.